Hello.
Hello?
Okay. So can you hear me?
Yes, sir.
Okay. So I already write the code for all of those things. So now
Okay.
I'll show you all of this result one by
O-
one.
Okay.
So let's just I simply share my screen.
Hmm.
Okay, so now can you see my screen?
Yes, sir.
Okay, so basically this is our requirement about that. First of all, we need to create the land use land cover map for Europe 2023.
Yes.
Then also make the LST map for 2023. And
Hmm.
then we try to make the interrelation between the land use land cover and LST. Okay.
Yes, sir.
So in this time we are just for each classes, suppose for the water, what is the LST value for and then for the cropland, for the vegetation, for the barren land, for
Hmm.
individually all of those land use land cover classes, what is the condition about the LST? We try
Hmm.
to show in here for the interrelationship. Then we
Hmm.
make the time series chart for NDVI, NDVI, and LST, and also
Yes.
make the correlation analysis, mainly NDVI and NDBI with urban heat
Hmm.
island after making that.
Hmm.
Okay. And then all of code is ready for that. Also, we can easily download all of the steep images. For
Hmm.
that, you can easily make the map using the ArtMap software, QGIS software. Okay, so
Okay.
let's go about the result.
Hmm.
So here you can see the display the result. First of all, one by one, I show you that the layer,
Okay.
and then show you the process about that how we can easily create.
Okay.
So
Okay.
first of all,
Sir, can you record it?
okay, I'll record. Yeah.
Yeah, record it, please.
So in this time, first of all, this is the land use land cover classification map here we
Okay.
created
Hmm.
and classified for water body, then
Hmm.
cropland, vegetation, barren
Hmm.
land, build up area.
Okay. Okay.
Okay, and we are also get the very good accuracy about that. We can get that for this map. We can get that accuracy is that for that 95% accuracy.
So,
From
which validation have you used for this?
in this time we are using at that random forest classifier, and we take the accuracy, and we can get the kappa accuracy is that 94%.
Okay.
Okay. So
Sir,
95% is the kappa accuracy,
okay. Yeah.
as well
Can
as
you
we can.
zoom in
Yeah,
for the urban area?
just a minute.
Yeah. Uh, Actually, can't we get the parcels here, like built up for the like buildings parcels,
Parcel means
building boundaries
okay, it also
built up?
possible. Okay, suppose only for the you want to just make the build of area boundary. Yeah, yeah, possible for that. It also possible. Suppose you just make only for the build of area boundary. Okay, such as
Hmm.
here I will show you the example. Suppose in this time you can
Hmm.
see this. It's only for the water body boundary. I will put the one example for that. But when I set
Okay.
the build of area, then it will set about. So in this time you can
Okay.
see all of those water body. We are
Okay.
just make a boundary or parcel about that. Okay,
Okay.
only for the water body. But
Yes.
it's same process we can also apply for that build up area. We can just make the parcel or boundary only for
Hmm.
that all of this build up area.
Hmm.
Here you can see in this time the water body we are just do that, but it also possible to that, no problem. So this is the LLC map, and
Hmm.
after that we are just created that we are also need the NDVI map.
Okay.
In this time we use the default color, but when you want to export it, and you can easily make the proper color from the ArcMap software or other thing.
Okay. And
Yeah.
one thing, um, I just need that particular image, satellite image also for that LULC. Can we
Okay, no
download
problem.
that
Yeah, yeah, we
image?
can also download the satellite image from here. No problem. We also said about that.
So how?
Okay. And then you can see here,
Mm.
this is the LST map,
Okay,
land surface
that's fine.
temperature monitoring.
Yes, sir.
for year of 2023.
Okay.
Okay. And from that LST, we are just apply the formula for Arvanit Island formula. Then we can get this Arvanit Island map.
Mm.
And in this time for the cross-sectional profile of Arvanit Island, suppose mainly we find out the for the rural area or where is
Mm.
the not density, more density of the urban area, we can get the low temperature. And for the
Mm.
urban or center urban, we can get the high temperature. So for
Mm.
doing that, we have to make this type of cross-sectional profile or a stack profile. Just we can simply draw the line about that. And corresponding
Okay.
this line, we have to create the profile of Urban Heat Island. Okay, so it
Okay.
also easy process to use the QGIS software after downloading this Urban Heat Island. We are just simply draw this line.
Mm.
It automatically create the such elevation profile or this type of things we can easily get from here from the QGIS
Okay, we
software.
have to download plugin QGIS.
Yeah, we have to download the this plugin name is that. Okay, I'll show you that just a minute. So I already download that. So QGIS software. We simply import that, then we can simply draw the stack profile about the Arvanit Island.
Okay. So how you get that urban heat island? What formula?
Okay, I show you that just.
Yes. Sir, is it recording?
Yeah, it also recorded. Just. So they simply search here Arvanit Island formula. Arvanit Island is in temperature effect is calculated the daily average global radiation, the
Mm.
maximum minimum temperature difference,
Mm.
and daily average wind speed. Okay, formula. Yes, so also another paper about that.
Mm-hmm.
Yeah, so this is the formula about that Arvanit Island.
Mm.
Equal mainly this is the average LST
Mm.
minus, sorry, it is the LST minus average LST divided by
Okay.
standard deviation of LST.
Okay.
Okay, so this is the formula about the Arvanit Island. So
Mm.
we already create the LST map. So now from
Okay.
LST map we just simply subtract about that average LST value divided by standard deviation of LST value for this
How we
specific
get these two
region.
values?
Yeah, for that we have to calculate this value from here. Okay,
Mm.
I'll show you the one by one just a minute. Okay, so in this time we can get the LST and also get that Arvanit Island. Okay, so
Yes.
now I describe about that how I can do all of those things or method
Mm.
about that all of those things
Mm.
one by one from this code.
Mm.
So
Mm.
first of all, here you can see first of all in this time this is the image. In this time here we use here the surface reflectance image, Landsat
Okay.
surface reflectance image. Okay,
Mm.
this is our image collection we are using here. And from here in this time we are just use here the specific image, single image, okay, for creating the LST, not create any
Okay.
types of composite. We are just take the single tiles, because for this study area single tile is enough. It fully cover
Okay.
our region of interest, because it's not so big, it's a small
Okay.
region. Okay, so in this time this acquisition time of this satellite image is that year of 2023 22 February. Okay, so this is the
Okay.
time about that. This time satellite image we are using here for making the land use land cover classification map. Okay,
Okay.
and this is our satellite image. You can see this satellite image.
Okay.
This is the image about that. Okay, so this is our satellite images. We can get very clear satellite images. We are just use this satellite image for creating the LST, as we'll also use at the land use land cover classification map. And this
Okay.
acquisition time is the year of 2023 22 February.
Okay.
Okay, so after that, first of all, we have to create some training sample, because in this time we are applying here the supervised machine learning, and supervised machine learning must you need the getting the training sample. Okay, so
Okay.
in this time, how much training sample I can get from here? I can get total training sample 560. Okay, training
Okay.
sample I take for this. Suppose water, then cropland, vegetation, barren land, and build up area. So all of
Okay.
those I took total 560 point. Okay,
Okay.
and how I can take the training point? Very easy. Just you can simply take the new layer, and then suppose take the new layer, then click on here, and then
Okay.
put the name, feature collection, and put the
Okay.
property name. Okay, so using this process, you are just take this training points as you can see water body.
Okay.
We take the cropland, vegetation, build up, barren
Yeah.
land. We just take this training point from
Okay.
the
Okay.
satellite images. Okay.
Yes.
After that, we are just simply extract some pixel value, or it's also called the spectral signature for each pixel value. Suppose this training sample, I just extract the pixel value. So this training
Okay.
sample, I extract the pixel value. So here total
Okay.
560 points. I extract the sum band pixel value. So in this time, I need to choose which band I want to use in here. So in this time, here I use this type of band. So SRB2 band, B3, B4, B5, B6, B7. So basically,
Okay.
this type of band is ready-made band. It already available in our satellite images. But for the acquiring the more better accuracy, here I also add this type of NDVI band, NDBI band, MNDWI band, BSI band, EVI band. So when I
Okay.
use this type of external band, then my this type of point also extract about the NDVI value, NDBI value, MNDWI value, BSI value, EVI value. So all of those value extract. Okay, then I can get the more powerful data set. Okay, so
Okay.
that's I can easily differentiate, because for the cropland and forest, this NDVI value is not same. Suppose for the cropland, for the build up area or barren land, this NDVI value is not same. Okay, it's some difference about that. When I want to add this type of external band, then my data set easily differentiate. This is the cropland, this is the
Okay.
vegetation, this is the build up, this is the barren land. Okay, but when I use only for this type of band which are available in the satellite images, then it's very difficult to identify for the barren land, build up area, vegetation, or cropland, because the spectral signature for the barren land and build up is almost same. Spectral
Okay.
signature of the vegetation and agricultural land is almost same. But when I put this type of external band, then it also more distinguished between each classes, and we are get the more better accuracy.
Okay.
Okay, so that's why in this time I also add this type of external band also in here.
Mm.
Then extract the pixel value. For the extracting the pixel value, you just call the image, then select all of those band. You can see this band is already stored all of those external band. Okay, then samples, mainly it is stored the all of those training sample. Okay, samples the variable stored. From here I just extract the pixel value. So now we are get all of those pixel value from here. You can see all of those classes pixel value. for each
Okay.
point. Suppose 0 number training point, here I can total 12 bands value. So here you can see for the I can get the EVI value, SRB2. So all of those value we can get BSI value, MNW value. So all of those value you can get in here for each point. So in the
Okay.
further we are just use this data set. So further we are simply separate the data set into the 80% data to use train my model and 20% data for test my model or check the
Okay.
validation. So that's why simply separate this data set. And
Okay.
further we are just use here the random forest classifier, and here you can see I put here the 210. Why I put the 210? In this time, when I put here the 210, then I can get the better accuracy. Okay, because here you can see it also another formula about to find out that 210. Yeah. So here I already had the chart. So here you can see when I put here the only for the 10, you can see for X, when I put here the 10, then I can get the accuracy is the 95%. Also, you can see the 30, get the same accuracy, no problem. When I put the 70, same. Okay. So in this time, 210 or 250, same accuracy you can get for all time.
Okay.
Okay. So now from here, you can choose any one value. Okay. And it's called the hyper parameter tuning. Okay. So basically, when I use this type of parameter, then I can get the better accuracy. And you can see it also 50. Then I also get the 95% accuracy about that. So this is the way for identify about the hyperparameter tuning. It also called the hyperparameter tuning. Okay, hyperparameter tuning mainly it's identify which is the best decision number of trees value to getting the best accuracy.
Okay.
Okay, so in this time we are just put here that and get the classify my data set.
Sir, you are recording this video, right?
Yeah, it also recorded.
Yeah. Thank you.
And here you can see this is the process for that identify about that hyperparameter tuning value.
Okay.
Okay, so after that we are just apply here that suppose check about the accuracy about what the accuracy we can get. So for the accuracy we are creating the confusion matrix table. Okay, suppose in this time we are calculating the confusion matrix table. And in this time, training accuracy can be two type. One is the training accuracy, another is the validation accuracy. So mainly training accuracy is that when you want to take the training point, how much error you can got. So in this time, you can say I can get the training accuracy is that 99%. So in this time, 1% is the wrong. Suppose I did not, I do some mistake when I want to put the training sample. Okay? 1% is the wrong. So it also calculate about that. You can see 99% is the training accuracy. And after that, validation accuracy. Okay. So mainly validation accuracy compared with the data set. So this is the confusion matrix table. Okay. So in this confusion matrix table, 0, this is the column. This column for that water, because here you can see when I put the water, I put here that 0. Okay. So it's a 0.
Okay.
Then this is the 1. Croplan is the 1. It's 1. Then 2. Then 3. Then 4. So 0 is the water. 1 is that cropland. 2 is the vegetation. 3 is the barren land. 4 is the build up area class. Okay. So in this time, this is the confusion matrix table. So it has another way to, if you want, you can also manually, if you want to calculate that accuracy from the confusion matrix table, such as mainly all of those right value. Suppose 13 plus 40 plus 17 plus 28 plus 16 divided by all of those value, then we can get the overall accuracy. So basically this is the formula about that. Suppose right value, mainly right value is that suppose 13, this 13 is for water. Okay. So and there is a nothing mixed with other. Suppose in this column is only for the water. So in this time there the other values is not mixed with that water. Okay. Also you can see it also okay for the 1, it also 40. So other value is the 0, it means that other value is not mixed in here. Also you can see in this time
What the 13 or 40 means?
So it means that about that pixel value. Okay,
pixel value.
pixel number. Okay.
Okay.
So pixel number. In this time here you can see the in this time we can get the two, mainly two is that vegetation. But vegetation is also mixed with the one number of pixel with 3. So what is the 3? 3 is mainly barren land.
Barren.
Okay. So in this time it mixing in here.
Mm.
As well as also you can see the 3 mainly barren land. Barren land is also mixed with that 2 number class. Okay, 2 is
Okay.
that mainly 0, 1 vegetation. It also mix.
Station.
Yeah. As well as also you can get about the 4. 4 is the build up area. Build up area is the 16, but it also mix with the 3 and 2 number land use land cover classes.
Okay.
Okay, so basically it's the wrong. Suppose 2 and 1,
Mm.
this value is the
Mm.
wrong. Okay, so
Mm.
here 1 is the wrong. Okay, as well
Yes.
as here is that 1 is the wrong. Okay,
Yes.
so it's the error. Okay,
Yeah.
so from
Yes.
here we can calculate the error matrix, and then further we just calculated about the what is the overall accuracy about our map. We can get the 95% accuracy. Okay, so
Okay.
mainly all of those right value summation. Okay, in this time what is
Okay.
the right value? Right value means that this type of value. Suppose here we can see, you can see the confusion matrix table first, then we can
Mm.
easily get that right value.
Mm.
Right value mainly 13 plus 14
14,
plus 17
17,
plus
28,
28
16.
plus 16, which is the
Yes.
right value. Okay, so
Yes.
summation
Okay.
of right value divided by all of those other values summation, then we can
Okay.
get that overall accuracy.
Okay.
And further from the overall accuracy we can also calculate that kappa accuracy. So kappa accuracy has the another formula. We can
Okay.
easily and in this time, basically in this time, Google Earth Engine platform has already this type of built-in function is available. So when I put this type of built-in function, it
Mm.
automatically calculate that. So in this time, don't use any types of equation, just put the function. Such as you can see the confusion matrix table. So when I put the confusion matrix table function, it
Mm.
automatically calculate the confusion matrix table. When I put here the accuracy, then it automatically calculated the accuracy.
Okay.
Okay, so this is the process about that. And finally, after accuracy, we are just show this our map, land use land cover map.
Mm.
Okay, so here red color identify about the build up area, blue color is identify about the water body, yellow is the barren land, pink color is identify about the cropland, okay? And green color identify about the vegetation or forest.
Okay.
So after that, okay, so we calculate the accuracy. So further we have to calculate the area. Okay, so in this
Mm.
time we are just calculating the area this type of way. We are just create this type of bar column chart, and we calculated the area in hectare unit. Okay, area in the
Okay.
hectare. So this is the hectare unit area. Okay, so in this time this is the process. So basically when we are use this type of function, it calculates the area in square meter. But when I
Mm.
multiply with this value, it calculates the
Mm.
area in square meter. So basically
Okay.
this function provide the result in square meter. But when I
Mm.
multiply these things 1 into 10 inverse force, we can get the result in hectare. Okay. So just
Okay.
simply click on here. Then we can get this type of result. And further you can
Okay.
download the Excel file or CSV file. And then you can easily
Oh.
create the percentage or other things you can easily create from the Excel file. Download the data from
Oh.
there.
Okay.
After that, for the okay, calculating the area,
Mm.
then we are also export this land use land cover map. So you
Mm.
can see the LULC 2023. So click to the run, it will
Okay.
be export in your Google Drive.
Google Drive. Okay. Mm.
And then we talk about the LST. Okay, after doing that,
Yes.
we talk about the LST. So for the
Okay.
LST, you are using that the mainly this LST, we are just put here that algorithm. I show you the algorithm first. LST land set etc.
Mm.
Okay, suppose you can see this is the one kind of algorithm.
Okay.
So in this time, I try to follow this algorithm and then calculated that LST for this region.
Okay.
Okay, So here you can see, first of all, they are take the Landsat satellite Landsat imagery and then calculated the NDVI using the near infrared and rate infrared. From this NDVI, they calculated the vegetation proportion or fractional vegetation. From that, calculated the surface emissivity, and they are also used at the brightness temperature. Mainly, it come from the thermal infrared band. Okay, so that's why we also need about the band 10 also. Okay, and then use this type of things. We are just apply this formula, mono window algorithm formula, and calculate the LST map. So in this time, we just follow the same algorithm and try to develop the code and then make this LST map. So let's go. So first of all, we need to create the NDVI. Okay, so in this time, we create the NDVI using the same image. So his image we are used to make the land use land cover. Okay, this image we are used.
Okay.
Same image. So for that, I simply put here the image. So this image, I just put the function normalized difference function. Mainly this function calculated that normalized difference between the near infrared band SRB5 and SRB4. So then when I put this normalized difference function, it automatically calculated SRB5 minus SRB4 divided by SRB5 plus SRB4.
Okay.
This equation automatically calculated, and we can get the NDVI map. Okay, suppose in this time we can get the NDVI map. Suppose this is the NDVI map.
Okay.
And if you want, you can get this type of color, because if you want to, when you download it, then we can easily get the better color. So in this time I set the code for the downloading for NDVI map.
Okay.
So I set the code for export that NDVI. So just use the same code. Just I simply call the NDVI, copy the variable name, and paste here, and put the description is that NDVI.
Okay.
I put the folder in India. When you want to in your Google Drive, you can easily it automatically create in the folder in your Google Drive. You can go to that and download it. So now it's really okay about the downloading the NDVI map also. Okay. And from this NDVI, we have to calculate it that, and in this time we also need to about that thermal band or brightness temperature band. Okay, so which is the band 10, and this band name is the STB 10. Okay, and for the rescaling in this time in Google Earth Engine platform, we have also to rescale factor for getting the proper LST value.
Okay.
So for that, in this time you can see the so this is the image about that I show you that. In this image we can get the band. This band is that STB10. Okay. So basically it's called the thermal infrared band, and this mainly provide the information for the brightness temperature on the surface, and this unit is the Kelvin.
Okay.
So further we are just converting to degree Celsius, and here we can get, just click on here, then you can get the full page about the data set. So this is the data set about that, and here you can see this is the scale value.
Okay.
And sorry, this is the offset value, and this is the scale. Okay, so simply we are using here this type of value for rescaling. Okay? So simply use here this value, you can see, multiply with that scale and add the offset, then it will be reprojected, then we can get the better value from here. And this is the thermal band about that, mainly it's the brightness temperature or ST band 10. Okay, so it's default color look like that. No, because it's not need for the exporting for the thermal band.
Okay.
After that, we have to calculate the fractional vegetation. Okay, so you can say the fractional vegetation or the proportion of vegetation. So for that, it have also a formula. This formula is that you can see NDVI value minus NDVI minimum value divided by NDVI maximum value minus NDVI minimum value and also power 2.
Okay.
So in this time when I put this formula, then we can get the fractional vegetation or proportional vegetation. So for that, we are just put here the, so in this time we need the in NDVI mean and max value. Okay, so for that we simply calculate the NDVI mean and max value from here. So this is the formula about that NDVI mean. So in this time we are just put this formula and get the NDVI mean value, you can see. So we can get the NDVI mean value for this study area negative 0.07, and also calculated about the max value 0.05. So there is a mean and max we can get. So now we are easily apply the formula, fractional vegetation formula. So mainly put here the NDVI, subtract with mean value, which is already available in here, and divided by max value minus mean value, and power 2.
Two.
Just put here the formula. Then we can get about that. And then emissivity. So for the emissivity has the another formula. You can see this is the emissivity formula is different for the region, such as you can see the town region and also natural region. Okay, so in this time it's a town, so that's why in this time put basically you also can see about the citation about that who provide this type of formula to calculate the emissivity for the town and natural surface. So in this time we are just put the town formula from here and then calculate that emissivity. So for that, simply put here this you can see this the constant value about that. Okay, that put the formula, you can get the emissivity from here. And then finally we are just put here the formula. This formula is that mainly mono window algorithm formula. So this is the formula for the LST. We are just put it in here, and this 273.15 we simply subtract from here, because for Kelvin, when you want to subtract the any value from the Kelvin 2073.15, then you can get the result in degree Celsius.
Okay.
For the getting the degree Celsius, we simply subtract this value from here, and we can get the result in degree Celsius. And finally, we can get the result in you can see LST result we can get from.
Okay.
Okay, and we can get the higher temperature for that our build up area and also for the barren land.
Okay.
Okay, so after that doing that, we have to put the Arvahani Island formula, which is the LST minus LST average value divided by standard deviation, this value. So for that, first of all, we calculated about the value of the average LST value. We can get the average LST value for this region is that 38.48. This is the average LST value, as well as also calculate about the standard deviation value. So which is the we can get the standard deviation value is that 3.12 value. Okay, and then simply put the formula LST map, which we already generate in here, subtract with this average value divided by standard deviation value. Then we can get the final Arvahani Island map from here.
External deviation value from where we'll get it?
We can get it from here. You can see this is the formula about that STDEV. Okay. So from mainly it comes from this LST map. So in the LST map, it generate the average result we calculate, also calculate about the standard deviation value.
Okay, sorry.
Using this formula ereducer.stdev. Okay. So now we can get the Arvahani Island map also from here and also visualize about that Arvahani Island map. So I also add the code for exporting the Arvahani Island map. So for that we are just use here the same code, just I simply copy from here, and we also need the export as a TIFF format for the further process of the map in ArcMap software.
Okay.
So just I simply copy from here this code. Just we simply change the variable name about that. Then it will be okay. Suppose Arvahani Island as well or LST map also download. So for that, just I simply first of LST paste in here. So just simply image I put here the LST.
Okay.
Description is that put the LST. And then same. There is no change about that. Okay, as well as finally for the Arvahani Island we also export it. So for that just use the same. So in this time image is the USI, and description is the same USI. Okay. Then same is that. There is no change. Okay, so mainly it's done about that. So further in this time we talk about the time series chart, such as this type of time series chart we have to create, such as you can see. So it's one kind of time series chart. Basically, it starts from the 2014, or I simply click on handle. So 2014 January. Then we can get the 2014. Okay, so from the download we can get the CSV file from here.
Okay.
So in this time it's that NDVI, as well as we also add here that it is the NDBI, mainly build up index.
Okay.
Time period we can get from here, and this type of chart we can easily download from here. We can easily download the Excel file. Okay, and further we can easily make the proper chart using the Excel file. So and also add the title. It also possible to in Google Earth Engine also. But
Okay.
Excel is very easily we can do it when you can get the
No.
data.
Yes. Yes.
And in then we also get this type of, this is the LST chart, I think. Yeah, this is the LST
Mm.
for this thing, for the, basically in this time, for this region we can get the data for year of 2014 January.
Okay. Okay.
So 2013 I also try, but it not capture. I don't know why. I think this is the, there is no satellite image for that Landsat for 2013. So that's why
Okay.
it not capture. It will be start from the year of 2014, 12 January, and
But
up to
actually, it's showing more
2023.
temperature like 71 degrees. Like,
This one.
94. What's that?
Okay,
Mm.
it show about this. Okay,
Band max. Sorry. What it means?
it's the maximum value in this time. It show about that. So okay, let's go set about the average value. Then you can get the better result. Just a minute. So for that, okay, for creating this type of chart, we are just put here. This is the equation for that NDVI, NDBI, and also put here that LST also. Okay,
Mm.
for the LST also urban area, I will also add in here. So in this time, so these are image collection.
Mm.
So for the chart, yeah, in this time we have to use the mean. Then we can get the better result for the LST also, because average. Okay, so put here the mean.
Okay.
Mean. Now we can get the better result. Mean. So now click to the run.
Mm.
Then check the chart again. Okay, it also loaded. In the meantime, we talk about that correlation. Okay,
Okay.
so mainly in this time for the correlation, in this time we are just take the data for year of 2014
Mm.
to 2023,
Mm.
NDBI, and Urban Heat Island. Okay, and then try to find out about their correlation, such as what is the correlation between the Urban Heat Island and vegetation index, as well as
Mm.
what is the correlation between the build up index with Urban Heat Island. Okay,
Mm.
mainly positive or negative. What is that? So for
Okay.
that, in this time, we are just create the chart on. In this
Mm.
time, we are just make the chart, and
Sir,
then yeah,
one thing.
please.
Can we correlate LST also with UHA here?
Yeah, suppose for the LST with NDVI and NDBI.
Mm.
Okay, it also possible. Same process.
Okay.
Just change the band name. Okay.
Okay.
Okay, suppose in this time,
Mm.
so I take the result.
Band mean.
Okay, so now LST is the okay.
Okay. Also error.
So correlation. Okay, so for the correlation, you can do some problem in here. Just a minute. Okay, so no band name SRP6. Let me try with 2014,
Okay.
because 2013 Lancet 8 2013 is available after April.
Okay.
Oh yes, it is also better for that. Use the 2014 to 3.
Sir, here we are taking from 2014 to 2023, right? In 2014, which month, which date?
It starts from the January.
Okay,
Okay.
to December.
Yeah.
So
So
it will.
23 December is not coming yet, I think.
Yes.
But for the recent update that
Hmm.
we can get
Okay.
now, check
So it will take the yearly average value.
as usually.
Okay.
Yeah, so now I can get the result, you can see, because for the 2023 we
Hmm.
can some band is missing, because
Hmm.
this image it properly start from the year of 2014. We can get the properly
Hmm.
for the Lancet 8.
Okay.
Okay, so in this time here we can get this type of chart. So basically it's
Hmm.
defined about the correlation chart, and for
Hmm.
the NDBI,
Hmm.
with in this time we can get the chart look like that. Mainly you can see it is the we can get the rise. Okay, so mainly it's identify about the positive correlation, mainly
Okay.
Arvanite Island and build up index. We find out the positive correlation, because
Hmm.
mainly where we can get the urban density or build up is the high, we can also find
Hmm.
out the Arvanite Island is also high. Okay, so basically it show about the positive correlation. Okay,
Okay.
and there is the another way is that if you want you can also check about the correlation. Suppose download the CSV file, and here I
Hmm.
already downloaded. We can get this type of value. You can see this type of value
Okay.
you can get from here.
Hmm.
Okay, so further if you want, suppose NDVI and USI, you can get
Hmm.
that value. And further if
Hmm.
you want, you can also make the correlation. Suppose
Hmm.
different types of Python library is also available, and then you can easily get about the correlation from here, also get the data. So in this time we can get the data. Basically this data is the mainly for yearly. Suppose
Okay.
1st January, 15, 16, 17, 18, 19, 20, 21, 22, and 23. We
Okay.
can get that yearly for the NDVI and USI, Arvind Island data. So from here you can also calculate it that different types of chart, and also calculated the correlation about that.
Hmm.
It's also use the Python library. Different types of Python library is available. Just
Hmm.
simply import the data, and it automatically make the chart also make about that. But in this time we gotta get this type of things. In this time we from this chart we can easily get it show about the positive correlation, because it's the rise. This chart is the rise. So this is the
Okay.
positive correlation about that.
Okay.
Okay. And further, when you want to check about the NDBI, what is the relation you can get from the here? So for the NDVI, you can check the NDVI. Suppose open this. So in this time, you can see this is the downward. So it's a downward. Okay.
Okay.
So basically, it means that when it will be downward, it's called the negative correlation. So
Once,
mainly,
can you open that CSV?
yeah, you can also download the CSV, and from here you can easily get the value. You can see this chart about that. We can get this type of value NDVI, and also get the corresponding Arvanite
Okay.
Island. Okay. So in
Okay.
this time you can easily do for the same for the Python or other thing, can make the chart also make about that. So basically in this
Hmm.
time when we can get the high NDVI
Hmm.
region, there is the low Arvanite Island. Okay.
Okay.
And where is the low vegetation cover, where we
Hmm.
find out the high Arvanite Island. So that's why it's
Okay.
totally negative.
Hmm.
Okay. So for the negative correlation, we can get from the NDVI and Arvanite Island. Okay.
Okay.
So you can see, you can also get about, they can see NDVI. So this is the NDVI, we can get that negative.
Negative. Okay.
Okay. And also check about the value. Suppose you can see, we can get the NDVI equal negative.
Hmm.
Okay. So it's the negative correlation with
No.
Arvanite Island. So basically you can see Arvanite Island in the equal to positive value we can get in here, but
Hmm.
corresponding value we can get in here also negative for NDVI.
Okay.
Okay, so from this chart we can easily get the idea about that. Arvanite Island is the positive, but for the corresponding value of the in you can get the negative. Okay, so
Okay.
basically it's a totally vice versa. Such as when I can get the high NDVI value, there I can
Hmm.
get the low Arvanite Island, where I can get the low NDVI value where you can find out the high Arvanite island.
Okay.
So this is the result about that for that.
Mm.
And for that, in this time, we are just choose this type of analysis. So for that, we need to create the collection. So in this time, you can also do for the LST also. So for the LST, what you can do? Just simply change
Okay.
here. Suppose in this time it show the USI, you can put here the LST because I already set all of the code. So in this time,
Okay.
suppose when I put here the LST, then this result come from the LST.
Okay.
Okay, so in this time we are not. You also change, no problem. Put the
Okay.
USI because I already
Mm.
make the LST band also in here. You can see I already
Mm.
create the LST band also, and then
Ah,
create the
yes.
USI band. Okay, so for that it
Yes.
also work for the same.
Mm.
Also for the LST correlation with NDVI and NDBI.
Okay.
Okay, so further in this time after doing that, we are just creating the uh, NDBI chart. Mainly in this time we create the two chart. One is the correlation for basically it's the correlation chart. NDVI
Okay.
correlation. Yeah, you can see USI and
Mm.
NDVI. Okay. When you
Mm.
need the LST, then simply put the LST and NDVI. Okay.
Okay.
And then also same do things for that also for chart for NDVI correlation chart. So you can
Mm.
see the NDVI correlation. I will write the comment in here. So just put here that for LST. When you need the LST, put here the LST, and then
Mm.
put here that your for the chart, put here the USI and put here
Okay.
LST and NDVI. So in this time we need the Arvanite island. So put here the
Mm.
Arvanite island and NDVI. Okay, then we can get the result for the correlation for Arvanite island and also need get the result for that vegetation.
Okay.
So it's the correlation part is done. So after that
Mm.
we create the chart for each land use land cover class. Such as here you can
Okay.
see we already make the land use land cover classification map
Mm.
for this year. So now I want to check about that. What is the
Mm.
condition for each classes?
Mm.
Such as what is the condition for the water body LST for year of 2014 to 2023?
Mm.
What is the build up area? What is the barren land? What is the cropland? All of those things I have to check. So for
Okay.
this result is that you can see. Yeah, so okay. In this time we have also put the another problem is that so it show about that it across the limit 5,000 element. So for that
Mm.
in this time, basically this
Mm.
chart is possible to create at the same time. Suppose we are one line show about the water, another line show about that vegetation. Okay,
Mm.
so this type of result you can see. So in this time, our region has a lot of pixel value. So that's why in
Mm.
this time I separately do that. Such as first time I try to show the water, then show the vegetation, then build up area, then barren land, one by one. So
Okay.
okay, working this. Yeah. So for that here you can see this is the water body LST chart for water body. You can
Okay.
get this type of chart as
Mm.
well as it will be start from the year of 2014. Okay, 2014
Mm.
January. Okay. As well as we are also make this LST chart for cropland. What is the condition
Okay.
about the cropland for different time? We can get from here LST chart and LST chart for the R1. What is the for the urban region? What is that? We can also get from here.
Okay.
And then we are also okay in this time we also get some. You can see it show about the user memory limit exit. So in this
Yeah.
time, we can get this problem for the vegetation because for this study area, we can get the
Mm.
lot of vegetation boundaries high. Okay, so there's a lot of vegetation. So that's why in Google Earth Engine platform has some limitation to making the chart. Okay, so
Okay.
that's why we have also need to put the another method. We are directly
Mm.
download the data in Excel file without chart.
Okay.
So I'll show you the later just a minute. And then also okay for the barren land, we can get the barren land chart. In this time we can face the one problem.
Sir, once
Yeah,
click on that points, so it's
yeah,
showing some date, right?
yeah, date, yeah,
March 17, 2014 data.
yeah,
But
January 12, 14, yeah.
Yeah, can't we take the same date data?
I think it's the same. Just a minute. So for that,
Hmm.
January 12,
Okay.
March 17.
Hmm. Okay,
Yeah.
okay.
So
Yeah.
basically it's the same, because
Yeah.
in this time we are using the same image,
Okay, okay.
extracting all of those things.
Hmm.
In the April 11, 2023, last
Hmm.
April 11, 2023.
Yes, yes,
It's the same date.
yes.
So then after, okay, so for that, okay, so I also write
Hmm.
the code, just a minute for that. So in this time, this is the code about that, for doing that, all of those things. And if you want, you
Hmm.
can also get the building boundary, only for the building boundary. It also
Hmm.
possible to that. Just I simply add here the map dot add layer,
Okay,
and then I already write the code for the urban building. Simply
okay.
copy and paste,
Hmm.
and then I show this result. I put the layer name, suppose
Hmm.
urban. Click to the run. In this time, we also get the only for the urban boundary as a vector file.
Okay,
So now it's urban. Okay. Now it make about that. I zoom in, then also get the picture. Okay, so this is R1.
okay,
Okay, all of those road, all of those building, all of those settlement now convert as a polygon.
okay,
And from here, if you want, you need only for this. Suppose you want to export this urban only as a
hmm.
boundary, and then
Hmm.
use it other software. It's also possible to that. So for the we are just export the shape file. So suppose just
Okay.
write the code export table to drive. Just I write that, suppose just make the curly bracket start, and also put this curly bracket int.
Hmm.
So first of all, collection this time I want to collection for the urban.
Okay,
So for that class urban,
okay,
simply copy and paste. And description, I put the description such as suppose urban
okay,
polygon. Polygon. Don't
okay.
put any name. Then folder, I put the
Hmm.
same folder name. Suppose, then in this time file format, simply put the file format is the shape file. So just put here
Okay.
that
That
SHP
is
shape.
SHP. Okay.
Then if you want an KML file, KMZ is also possible to export from here, no problem. Okay. So now
Hmm.
it also export about the shape file for the urban, for the only for the
Hmm.
build up region.
Okay.
Okay. So for that, suppose which region is not work for that, for the
Hmm.
chart, because it's a lot of pixel value. Okay. But
Yes.
chart is not possible to create. So for that we have to put the another option. For
Hmm.
that, in this time we are just export as a CSV file. Okay, so here I already write the code. So for that, in
Okay.
this time we are just call the image. So his
Hmm.
image I want to use in here. So
Hmm.
from this image I just filter bounds only for the vegetation area. right?
Okay.
So then select my, I want to extract the LST. So put here the LST map. Then all things will be same. Okay, so now you can see click to the run. It will be you can easily go to the task tab, and from here you can easily download the data for the vegetation
Okay.
LST hello as a time series data in Excel file or CSV file. From here you can easily
Okay.
make the chart.
Mm.
So now work. So here you can see all of those files I add in here,
Mm.
such as LST, Urban Island, NDVI, LULC 2023. Okay, also you can see the export this file. Okay, so basically you can change the name, it also better. Suppose I put this name is a
Vegetation.
vegetation LST.
Mm.
Vegetation. And which is missing, suppose okay, USI, LST, NDVI, LULC 2023, and it is the vegetation LST and urban polygon.
Urban polygon. Okay.
So now, okay, so okay, NDBI. Okay, so you also need to the NDBI export for that PPMS.
Yes.
For the NDBI, it's very just I show the right that. For the NDVI, so it's done. For the NDBI, vegetation build up index map. So for NDVI, so for NDVI map, we need the NDVI map. So for the NDVI map, we are just use here NDVI. So I write the NDVI in here. So first of all, show the NDVI map. So suppose map.add layer and show the NDVI map. Copy from here. And then it's clip with study area ROI.
Mm.
Then click to the run. Let me check about the NDVI map result. Okay, so for that we have so need to also put here the mean or average value for reducer average NDVI value. So work now.
Sir, one dot for NDVI, it's taking like in January some date in 2014. For example, and 2015, it's taking in March, right?
Yes.
Can we make it as a single date for the every year, like 2014? It's March 1st, like that.
It was possible to that.
Where we have to change for that?
Okay, that's done. With the NDVI visualization
Okay.
and also just put here curly bracket and put here the mean. Start from that, copy this value and paste here, and also put here the max
Okay.
here. We copy this value, paste here, and set the color. So suppose I put here the color. Let I just make a list. This is blue. But that put here the suppose white. Put here the suppose red. And put the layer name is that NDBI. And I also want to export the NDVI map. So for that, just use your export image to Drive. Put all of this argument one by one. So just make a dictionary. Curly start. Curly bracket
Okay.
first of all image.
Mm.
NDVI image is that simple. From here the full portion from here. Description, I put the description is that NDVI.
Okay.
Folder I put here. Then it's not need, I simply remove that. Region is the shapefile variable name. So mainly is that ROI.
Okay.
Scale is
Scale
the
30.
30 meter resolution.
Mm.
Other thing don't need simply. So now it also added the export option also.
Mm.
From here we can easily download also.
Mm.
Okay, so now for the time series chart, what you need?
Mm.
Okay, so I can see also about the NDBI. And we
Yes,
also get
yes.
this type of NDVI map also in here. So you can easily export it from here and then work with dark map or QGIS software.
Sir, for which year that one?
Yeah, yes.
NDBA for which year?
NDVI is mainly calculated that for year of 2014 to 2023 average value.
Okay, what is one? Yeah.
Okay, so basically this is the TP image for all of those, and we are also okay. So try to run this and what the result we can get from here. Check it for the CSV vegetation LST value time series chart. Okay, so now it's we're working. You can see. So after some time, it will be extract the value from here. Okay, as well as we also need to the export this satellite image also. Yeah.
Yes, yes.
Okay, just a minute.
And I just want to get the every year LST, NDVI, NDBI
Yeah. So time series chart.
images. Images also, year-wise images.
Here while image is also possible. Yeah, it also possible. For
Mm,
yes, suppose 2014, then 15,
mm,
16,
mm.
17,
Yes.
18, 19, 20, and up to it also possible.
Mm. So you are basically from computers background.
No, I'm geography and environment.
Oh, but you are doing good in programming.
Yeah, so just practice for that.
Okay.
Okay, so now it also said about that imagery. So now I
Mm.
can easily download the all of those band. In this time I set it only for the three band, red, green,
Okay.
and blue. But when you download it, you can get all of those band also.
Okay.
But sometime okay, so will I add only for the three band or other band also you need?
All the bands.
Okay, so okay, you also try to first check all of those exporting. Sometimes you face some problem for exporting, then let me know. I also get you the support, no
Oh,
problem.
okay.
Sometimes when it lot all of those band have a lot of this file is also very high or big, so that's why it's some
Okay.
problem for exporting this type of
Mm.
things. Okay, then we have
Okay.
just need to some modification, then it will be okay, no problem. Okay,
Okay.
so
For the LULC purpose only right now, so we can have the three bands. It's okay.
yeah, three bands is also okay. So for the three band, we can
Uh,
simply select here dot select function select
okay.
and put here this three bands such as put the band name as a list. So put
Mm.
here that SR
Mm.
B4 red, then put here the SR B3 green, and
Okay.
put here the SR B2 for blue. Okay.
Okay.
So now it export only for that three band.
Okay.
Okay, but it has also another thing is that in this time this image we are also used to get
Mm.
that NDBI, which is need for the short wave infrared one band, and also short wave infrared two band. Also use here the STB10. So that's why in this time I think it also not set in here, because when I set this three band, then this
Mm.
image is calculating only for this three band. So other band
Okay.
is not
Okay.
counting. So that's why
Okay.
other code is also error for that. So in this time it
Okay.
also saved to not the select all of those band we consider and then work. It also better, I think. Yeah.
Okay. Okay.
Then when I set this only for the three band, then it also work only for the three band, and other bands it show there is
Mm.
the no band. So that's why you can get the
Mm.
error for the
Okay.
NDBI or LST.
Mm.
Okay. Okay, for in this time, suppose you need only for that yearly image. Suppose NDVI,
Mm.
USI, LST, NDVI, you need the yearly image. So for
Yeah.
that, it also easy. Just a minute, I write some code about that for
Okay.
yearly keep images.
Mm.
yearly TP image. Okay, so in this time you will see, okay, for NDVI and NDBI, we need the data for that yearly TP images, suppose. So for that yearly image collection,
NDVI, NDBI, LST, and LULC, sir. Four parameters.
okay, so for the, okay, so for LST we are using the single image,
Hmm.
because yeah, for
Okay.
this, suppose A level C, we can A level C and LST. So these two things we are use the same image.
Yes, yes.
Okay,
Same
for the
image.
single time, which is start time is the 22 February 2023.
Okay.
Okay, so for the single image, it's not possible to create the time series or annually. But
Okay.
for the NDVI,
Hmm.
it is mainly this result show about the mean value total
Hmm.
year of 2014 to 2022 3. So these
Okay,
things we
okay.
can display for that, also do for the NDVI also.
Hmm.
So for that yearly TP image. Okay, suppose in this time it will be start from the year of 2013 to 2023.
Yes.
Okay, maybe we can get the result 2014.
Hmm.
So just I put here suppose 2014. So suppose 1st January from 2023. So in
Okay.
this time, if you want, you can randomly put the date or get the result. So it is the one way. I think otherwise it also possible to do that. But further we have to write the lot of code for do that.
Okay.
Suppose in this time you need the result for in this time this result
Hmm.
show about that total all of this year from year of
Hmm.
2014 to 2023. Suppose you
Hmm.
need the result for NDVI, NDBI, TPMS, and also need for the time series chart for the 1 year.
Hmm.
So for that you can
Okay.
simply change the time in here. Suppose put the 2014 December 31.
Hmm.
So now I can get
Okay.
only for the 1 year TPMS as well as
Okay.
also get for the 1 year time series.
Okay.
Suppose let's check the result. Suppose I change it. So now click the run. In this time, we can get the result for 1 year time series chart of NDVI,
Hmm.
as well as we will also get the time series chart 1 year for LST, for 1 year
Hmm.
for NDBI, 1 year
Hmm.
for Irvine Island. So all of those things we
Okay.
can get only for this time. When I put
Okay.
the this time here, single annual time period. Suppose in this
Yellow.
time I already had about the NDVI and LST. So for the
Hmm.
1 year, we can get all of those times chart.
Okay.
Suppose 1 year times chart. It's generating. Yeah, I can see. Only for the 2014. Okay. In this
Hmm.
time, simply this chart represent only for the year of 2014.
Okay.
Okay. Suppose click to the download. So basically, year of 2014, all of those images. Suppose for the 1 year, I can get for the 3 images or 4 images. In this time, it show about the 3 images. Okay. So
Okay.
further, I can get for the 3 images value.
Hmm.
Okay. Mean value. It show about the three
Okay.
images mean value. we can get the
Okay.
2014. And suppose you need for the TP image. So in the it's a chart for 1 year or annual chart. And for
Mm.
getting the TP image, suppose you need the TP image. So for that, in this time, we are already add here. You can see NDVI. So mainly in
Mm.
this time, we can get this NDVI, which NDVI can get in here. It's only for the year of 2014, single
Mm.
year.
Okay.
Okay. And in the same way, suppose you need for this NDBI also. So same
Mm.
process. Suppose I also add this layer. Suppose map dot. Just simply copy the same code from here and paste here. Now we can get the single year NDBI map. NDVI
Okay.
map. Okay.
Okay.
Suppose you need the LST. Simply copy the same things from here
Mm.
and paste here. Now we can get this. Just put here the LST. LST. So now we can get the LST map for year of 2014.
Okay.
And you can also change the color, other things about that. Okay, so just
Okay. If we give the time range in the previous lines, then we'll get the average,
yes,
right? Mean.
yes,
If you give only for like Jan to December for a particular year,
yeah,
it only gives for the year.
yes, yes. So you can see simply change in here. Then we can get
Mm.
the result for that annually. Suppose year of 2014. Suppose you need the 2015. Simply put here the
Mm.
15 and also put
Mm.
here the 2015 December. Okay. Then we
Okay.
can get the 2015 all of this map for an
Okay.
also chart, as we'll also
Mm.
get about the map. And from here you can easily export the tip format from here for annually.
Okay. Okay. Got it.
Just use here the same code. You can see. Suppose in this time, suppose NDVI. When I want to put suppose same code, just simply copy from here or also change it.
Okay.
Suppose you can put here the LST and then mean
Mm.
clip and then put here the description is the LST and put the
Okay.
folder, and then we can get the data for LST also for
Okay.
the
Okay.
single year or a specific 1 year LST
Image.
image,
TIFF
a
image.
tip image. Yeah.
Okay.
So NDBI I write in here and
Mm.
LST. And in this time, when I want to put here the single year, suppose I just put here the single year, then this correlation. Okay, so basically in this time we can get the 1 year data for correlation.
Yes.
Okay, so
Mm.
1 year data correlation we can get from here. So this is
Mm.
another problem for that, because when you want to make the correlation, we have to use here the more data set. We need the more
Yes.
data set.
Yes.
So
Yes.
that's why you can, when you want to get the single TP image, then simply increase the date. Suppose year
Mm.
of 2014 to
Mm.
2023. Then it
Mm.
consider for urban heat island as well as also LST, NDVI and NDVI for this time, long
Mm.
time, and also calculated that correlation also.
Correlations. Okay.
Okay.
Mm.
Okay. So I will send you this code. You can also try to export all of those file from here and
Okay.
as well so do that. And for the second step, you also need about that for
Uh,
that heat stress vulnerability index. Okay, so in this time
yeah.
you want to put here the urbanite island,
Mm.
population density, green cover,
Mm.
NDVI and NDVI correlation data, and you want to
Mm.
put here the ASP process.
Yes.
Okay, I think ASP process is better to use the ArcMap software to
Okay.
get this stress
Any
vulnerability
other
index.
prediction software code is there? Like
Okay, for that
artificial
Google Earth
intelligence and
Engine prediction is not possible as a freely. For that we have to create the some Google Earth Engine prediction code or
okay.
get the some cloud code.
Okay.
Okay, so in this time ArcMap is also okay for this type of ASP process.
Yeah, but it actually for a PhD related work.
Yeah.
So it's better to I think have like artificial intelligence or machine learning code uh, by using this GW. So
Okay.
what you say?
Okay. So for
For
that,
prediction.
okay, for ASP, okay, I also try to find out some method about that.
Yeah.
For that, then I'll let you know about that. For that,
Okay.
what, yeah, is there any coding related when you want to do that? Then it also better for that.
Oh, okay.
Yeah. Okay. So I'll let you know. So
Okay.
our first phase is done. So as soon as
Yes.
possible, we also meeting about that second phase, and then
Okay.
try to, yeah, in the meantime you also try to send me about the population density map.
Ah,
You can
yes.
provide as
Yes,
with the,
I'll give you the point data.
yeah, point data. From that we can just use the interpolation and
Yeah,
then make the
information.
density map. It also better.
Yeah.
Okay, no
Okay.
problem. Okay,
Definitely.
okay, thank you.
Okay.
Okay,
The-
okay, have a good night. Okay, bye.
Yeah. Just send me that video link. Okay.
Okay, thank you. Okay,
Yeah. Thank you. Tomorrow we'll discuss about how to transaction. Okay.
okay, okay, thank you. Okay,
Yeah. Yeah.
okay.
How you are doing this transaction like because it's an international transaction, right?
Yeah, I can. I no problem. I have the some agent in the India. You can easily do that. No problem.
Ah. Okay. Okay. Then no problem.
Okay, thank you. Okay, have a
Yeah.
good. Okay.
Thank you. Thank you.